Good afternoon. My name is Santiago Boscan. Today I'm accompanied by Sidney Bobadilla, Adolfo Cabrera, Nicolas Yaman, and David Vasquez, and we'll be presenting a stress and anxiety management application owned by the CEO of HR Vision Consulting, Lian Sangoyo, for a capstone senior project. Next slide, please. According to the academic article, Application for Population Mental Health by Jade Adler and D. Van Brunt, more than 40 million adults in the US experience a clinical anxiety disorder. This study highlights the rise in reported cases of stress and anxiety among American adults. At the same time, this study also shows that around 80% of Americans owns a smartphone, which creates a powerful opportunity. With mobile devices being such an integral part of daily life, they can serve as an accessible platform for mental health support. This sets the stage for digital tools to monitor the well-being of users and help them build healthier routines. Next slide, please. As such, our problem is to address the need of a mobile application that helps users manage stress and anxiety. Our goal was to work on an application developed by previous groups of senior students to guide users with activities to support them in their journey of managing their mental health. Next slide, please. However, to address this problem, we had to tackle three main issues. Make an app with interactive activities that involve both visuals and auditory elements. Create reusable user interface components that are maintainable, and develop an application that can be used in both Android and iOS devices. Next slide, please. For this project, three key requirements were outlined. First, we were tasked with creating engaging activities that combine both visual and auditory elements, ensuring that the user feels immersed and supported throughout their mental health experience. The second requirement was to build reusable user interface elements using Jetpack Compose in the Android application. Compose plays a critical role in constructing UI elements using a modern approach, as before the user interface in the Android application had to deal with complex XML layouts and it required to manually change parts of the code to update elements in the front end of the application. Compose allows our team to modify parts of the UI without altering the current state of the application, which makes developing new features faster, make testing easier, and allows for components that can be modified independently without altering the program's behavior. For example, in this project, we created text cards with Jetpack Compose that can be reused throughout different parts of the program, and modifying the content of the cards will not affect the behavior of any other part of the program. Next slide, please. Our last requirement was to develop an iOS version of the application that includes the core features of the Android version. This ensures that both platforms provide a consistent experience, allowing users on any device to access the same tools. By building clean and reusable components in the Android version, we could start developing the iOS version with a strong design foundation that allows us to port the core functionalities in a shorter period of time. Now I'm handing over to Nicolas so he can explain how implementation was handled.
Good afternoon. My name is Nicholas Druman, and I'm going to be talking about the implementation and current state of the app, How Are You Life? I'll start with the implementation of the Android application. The IDE used was Android Studio because it's an industry standard tool for Android development and has easy debugging and built-in emulator. The framework used was Android SDK and Jetpack Compose because SDK gives access to device features and Compose makes user interface building faster and simpler. Colton is the official Android language. It's safe, concise, and easy to maintain. Finally, the database used was Firebase because it's a cloud-based backend and handles authentication and real-time data. Next, I'll move to the implementation of the iOS application. The IDE used was also Android Studio through Flutter, as it provides consistent tools across both platforms. Framework used was Flutter, as it has a cross-platform user interface framework and a single code base for iOS and Android. Dart is the official language used by Flutter. Finally, the database used was SQLite because it's a local database used for storing data on the device and is easy to integrate with Flutter. Finally, for the implementation, I'll be discussing the project management. The version control used was GitHub, Git, and GitHub Desktop. The user interface design was Figma, and the graph design was draw.io. Now, the current system allows users to log their daily activities and displays data and graphs. As you can see, we use pie graphs, bar graphs, all for the users, as well as provides guided exercises for the users depending on their needs. Now I'll be passing it off to Aldolfo.
In here, I will tell you, hello, my name is Adolfo Carrero, and here I'll be telling you about the object and system design. In this slide, the object design for the system, each box represents a class or entity our app uses. The object stores login information like email, password, and username. The reflection object stores the question that users answer daily. The control gauge, stressor, and mood track the user's emotional data. All of these connect to the database manager class, which handles saving, retrieving, and updating the data in the database. Next slide, please. And here, this shows an example of how one of our objects, the mood object, is stored in the database. We created a table called mood with fields like ID, date, mood level, and when it was created. This shows the connection between our object design and actual SQL table structure in SQLite. Next slide. In here, this slide shows the overall system architecture. At the top, we have users interacting through the app's screens. The database manager class sits in the middle and acts like as the communication layer between the UI and the SQLite database. Below that, we have three main tables: user, data, activity data, and preferences. These tables support features like mood tracking, control gauge tracking, and stressor tracking. All of this information is stored in the SQLite database at the bottom. Next slide. Here is an example of how the system retrieves data from the SQLite database. This function, getMood, takes a date and tries to find a mood user recorded on that day. First, it connects to the database. Next, it converts the date into an ISO 8601 string so it matches the format stored in the database. Then it queries the mood table, looking for the row where the date matches the one user selected. If it finds a result, it returns the mood value. If no record exists for the date, it returns null. I will now be passing it to Sydney.
Hello, my name is Sydney Bobadilla. I will be presenting the verification and the feature features. For our verification process, we focus on three main areas. First, testing the technical behavior of the system, things like the UI components, database operations, and overall user interactions. Because we developed for both Android and iOS, we had to make sure each version performed consistently across platforms. Second, we ran tests that simulate real user behavior. This helps make sure that what a user sees on the screen truly reflects the data they input, like mood logs, activities, and guided exercise progress. And finally, we validated the application with the product owner to confirm that the features and design choices align with the real needs of a mental health focused system. Next slide, please. For the first specific verification method, we focus on a structured user test case. Since this is a mental health tracking app, one of the most critical interactions is logging moods and emotions throughout the day. This test case checks whether the system accurately captures and displays this information. In our example, the user selects a neutral mood for November 28th through the mood selector on the app. The expected result is that the dashboard's feelings bar should immediately display that neutral entry for that date. This may sound simple, but it actually validates several key parts of the system at once. First, that the interface properly captures the user's input. Second, that the database, Firebase, and for Android and SQ Flight for iOS stores the entry correctly. Third, that the dashboard retrieves and visualizes the data without delay or errors. The final part of our verification involved presenting the Android and iOS applications to our product owner. This review focused on usability, effectiveness, and overall alignment with the goals of a stress and anxiety management tool. During the review, we demonstrated the full workflow, from logging moods and activities to the guided exercises to the graph-based visualizations that show emotional patterns over time. This allowed her to evaluate whether the app would be genuinely helpful and intuitive for real users. Her feedback confirmed two important things. The first was usability, ensuring the design was simple, clear, and easy to navigate, which is crucial for an app meant to support mental wellness. And the second was complete functional completeness, verifying that the features we implemented matched the original requirements and behaved reliably across both mobile platforms. Looking ahead, we identified several future features that would enhance our app beyond its current capabilities. The most significant one is creating a fully unified user interface across Android and iOS. Right now, the Android version uses Jetpack Compose while the iOS version uses Flutter. And although both apps function very similarly, a unified UI would help ensure that every user has the exact same experience visually and interactively, regardless of their device. Beyond that, there are additional features we envision as next steps. For example, we could introduce more advanced analytics to help users see long-term emotional trends, or we could also include personalized exercise recommendations based on a user's activity patterns. Next will be the summary with the next presenter.
Hello, my name is David, and to conclude with this presentation, How Are You Life provides a simple but powerful way for users to understand their mental well-being. By encouraging daily check-ins and storing those entries in a secure database, the app helps users visualize emotional patterns over time. This insights helps individuals to recognize what affects their stress levels and make more informed decisions about their mental health. With a clean interface, guided questions, and visual dashboards, we can change the slide. How Are You Life is more than just a tracking tool. It's a supportive companion designed to promote a long mental wellness. Thank you.